Bonjour à tous, comment ça va? Bien. Excuse-moi, je parle en français juste un petit peu, mais pas rapidement. Alors, je continue en anglais. C'est bon? Okay. Welcome to this session, Code Coverage in Practice. My name is Evgeny Mandrikov, and I'm working for SonarSource company, producing such a product that you might know, SonarQube. But today I'm going to talk about code coverage, something on what I work in my spare time. Just to align us before we go deeper, quick, let's say, alignment. Nowadays, let's say we have some application. In order to ensure that this application behaves correctly, what do? We do write tests. So tests is a way to ensure that our application behaves correctly. Among other ways like mutation testing and so on, the simplest way to verify that our tests are complete is to use code coverage. This creates such a loop between our application and tests. And so we are going to talk about code coverage. A bit of history about code coverage tools for Java. Back to 2004, there was a great little tool called EclEmma. Actually, not just was, it is still there, but unfortunately, since the first release, there was never any other maintenance update or release. Based on this library, back to 2006, there was developed Eclipse plugin for code coverage by Mark Hoffman in order to simplify measurement of code coverage in Eclipse. And this was a version 1.x. At some moment of time, it became quite obvious that EclEmma is not going to evolve, but Java evolves and other tools evolve. So there was started an effort to develop a new library with the new features like branch coverage and so on. Also by Mark Hoffman. A little bit later, I joined his efforts on this library. And at some moment of time, this library superseded the EclEmma in EclEmma, but the name stayed the same, a combination of Eclipse and EclEmma to not disturb our users with rebrandings and so on. This library, JaCoCo, is tested on 5 major JDK versions to be sure that it covers the needs of any user, from user of JDK 5 up to the JDK 8 and nowadays as JDK 9. Thanks to this testing, we do not only identify issues in the library, we also find issues in JDK itself. We even have a special tag in the bug tracker JaCoCo found. Apparently, we are in top of 5 contributors of bugs, along with Apache Tomcat, IntelliJ IDE, and so on. This is possible thanks to our validation test suites that looks like what you can see on the screen. In the code, we write a code and then we assert that what is going to be displayed to a user as covered or not covered is exactly what's supposed to be displayed. But okay, why we all here today? Because at some moment of time, we decided to move EclEmma project into the Eclipse Foundation. And this become a version 3.x. And so now, nowadays, EclEmma is an official Eclipse Foundation project. proposal was accepted, let's say, a year ago. There was an initial contribution. We have now code under Eclipse Foundation. And version 3.0 is part of Oxygen because we believe that code coverage is needed for you as Oxygen. So you don't need to install it anymore. You're going to get it already bundled with standard distributions like Eclipse IDE for Java developers, for Java EE developers, and so on. Mostly there is no new functionality in EclEmma compared to the previous release 2.3.3, except that, okay, we changed the namespace. Almost. It is updatable from previous version, so transition is supposed to be smooth. We did some improvements so that it fits better in Eclipse Oxygen. We provided HDPI icons. It still works on Eclipse versions 3.8 and greater. And among other improvements, it's already Java 9 ready, thanks to the JaCoCo library, which is Java 9 ready. What code coverage can be used for? Of course, for unit tests, of course, for integration tests. More advanced use cases include usage analysis. We are going to see what this means, and differential coverage. A quite important note that Java code coverage library works for any code running on JVM. It's not only about Java, it is also about Kotlin, Gradle, and all the languages that at the end compile into Java bytecode. Another important note is that it's not intended to be used for profiling. Quite often we receive questions like why you don't measure time, why you don't count how many times line was executed. This is not a goal of code coverage tool. Profiling is completely different business with completely different requirements and restrictions. Along with Eclipse integration, there is a lot of other integrations with various tools. If you talk about IDEs, there is integrations with IntelliJ, NetBeans, and so on. If you talk about build systems, you don't need Eclipse EclEmma. You can integrate computation of code coverage directly into your build using integration with Maven, Gradle, and soon pretty simple command line interface. Of course, the same applies to continuous integration servers. Jenkins has a pretty good integration, and so on. There is a Java API, so if you lack some integration, you just develop your own. Probably this is enough for blah blah, and it's time for a little demo. Hopefully it will go well. So today, this morning, I just took Eclipse IDE for the latest downloading of Eclipse IDE for Java developers. On this page, as you can see, EclEmma supposed to be included in it. So here we are. We have release candidate 3, Eclipse Oxygen. We see that Eclipse EclEmma is installed. For the demo, I took EclEmma project itself and some tiny other project to demonstrate Java 9. So it is easy as is. You have a special launch mode, which is not that much different from already familiar to you, just run and debug. It is mode to run with code coverage. So having some tests, we can run it with code coverage. Oops. test takes a while. But at the end, we have our code coverage highlighting directly in the source code. Green lines are fully covered. Do we have, yeah, red lines are not covered. If we will have some branches, unfortunately in this example we don't have, we will see that a little marker showing that some branches are not covered. Also, what we have a little nice view displaying coverage of all the classes if our test suite targets different classes. We can drill down from the project level down to the package, to the file, class, method, and so on. There are various modes. We can see the covered bytecode instructions, which is default. We can see branch counters, line counters, method counters, and so on. Of course, we can configure colors if we don't like the default ones and so on. Oh, sorry, I was showing you a coverage of a test, which is probably not that interesting. The coverage of a code that this testing is here actually, and yes, you can see the branch markers saying, okay, in this case, all branches covered. In this case, one of 4 branches missing, so probably we don't verify condition. I would guess that we don't verify condition where filter is null, and so on. Moving to a more interesting stuff, I also installed beta support for Java 9. So here I have a tiny project targeting Java 9. Let's check this. Yeah, so we have Java 9 jury. If we run this with code coverage, oh, it's super fast. It's already completed. As you can see, it's running almost the latest nightly build of JDK 9, and we do have a coverage, so it's Java 9 already. All the same views and so on. Going further to more interesting examples, let's say I wanna run some application. For example, in this case, let's run Eclipse application in a coverage mode. It takes a while. So here is my application. If I will just stop this application as before, let's do this. If I just stop this as before, coverage will be analyzed, and I will see what was executed in this application. Since I haven't did any actions, we see the zeros here. Let's do some interesting action. Let's, for example, open coverage view. I don't know, let's in this application start something with the coverage. Why not? If I now close it, voila, we get a coverage of what we just executed in this application without having any unit tests and so on. We just see what was executed. But this is also not so exciting because we did a lot of actions, so we get a pretty good coverage. We covered almost 50% of our library. Let's do something more interesting, which is named Incremental Coverage. For the running application, at any moment of time, you can request code coverage as it is currently. So let's do this. I did 0 action, so it is empty. If again I will do some interesting action and request coverage, we will get exactly what we are getting if we stop application. But even this is not interesting. What I can ask to do is to, each time I request coverage from a running application, I can ask to reset the data. And this allows pretty nice use cases like, let's say, I probably forgot something. Let's say I want to explore which parts of code is going to be touched if I press some button in Eclipse. This is possible. We can say that analyzes, here. That analyzes scope not just includes our plugin, it also should include something else. For example, some of the dependencies. For example, let's say we want GDT UI. Yeah, it should be enough. So if we request data, we are already gonna get something because we executed the code. So yes, GDT UI was started, and so we see some coverage in it. Yeah, GDT UI was started, so this is something. Let's say I wanna explore what happens when I open Java editor. So to do this, we're gonna request dump, resetting the current state of coverage. Then we're gonna open Java editor and request dump again. And here we see that 3% of GDK UI is touched when we open Java editor. We can drill down, not a surprise that code that was touched is inside of Java editor package. We can drill even further down to the classes. If I would have sources for this external library, we can even drill down to the source code level, which is quite a nice feature to explore what happens on which actions. If you simply don't know from where to start fixing some bug or something like this, you don't know where to put breakpoint, you can use this feature and you will know where you can potentially place breakpoints and then use debugging. That's probably it for a demo. So let me switch back to the presentation. So it was easy, isn't it? The same applies for Maven integration. It's not that hard to integrate code coverage JaCoCo library into your Maven builds. It works with Maven Tyco, so it's applicable for your builds of Eclipse plugins. Even though it's easy, there is still sometimes some difficulties, so we do have some principles and best practices. And they're also about code coverage in general. Let me play a little game with you. Do you know the target value of code coverage on your projects? What you're aiming for? Do you want 100%? Who is shooting to reach the 100% coverage on your projects? No one? Yeah, 100 is pretty good value, but unfortunately in reality hardly reachable. Who is shooting for, I don't know, let's say 80%? Yeah, that's better. Maybe 60, even easier to achieve than 80. 40? 20? 0? Okay, I don't know what others do, but question in general, how you choose this value? Why 80, why 60? Just why not, some starting point, yeah, fair enough. So our recommendation, stop caring about percent value. Forget about the number. The main issue is untested code. So focus on untested code. Focus on this, not on a percent. And then over a time, if you care about untested code, and you will be testing it over time, you will increase your metric, obviously. The simplest way to do this is not just to say, okay, we have plenty of classes uncovered, let's cover them. No, the simplest way to focus on untested code and increase your coverage is to also focus on coverage of a modified and a new code. Okay, we are not a Google, but let's imagine that we are. Google claims that they rewrite something like 60% of their code base each 3 months. So if you focus on coverage of modified code, it means that after 3 months, you being a Google, you will probably cover 60% of your code base. Another 3 months, maybe there will be an intersection with previous, maybe not, but most likely you will reach 70 and so on. After years, when you will rewrite all your code base, you will reach 100, simply like that. Make your coverage analysis an inherent part of your build test chain, integrated into continuous integration systems, integrated into IDE. Make sure that everybody in the team are aware of code coverage, how to measure it, on what focus and so on, but not management. So again, don't look on percentage. Writing tests that just execute some code is useless, that don't have some assertions and so on. Very useless. It's gonna improve your metric, but it's not gonna give you any safety net. It's not gonna help you in ensuring that your application behaves correctly. So please shoot for functional coverage when writing tests. Please verify the real features. Please don't write the tests just for the sake of writing tests. Yeah, so just executing the code is not going to improve the quality of this code. In order to help you to focus on a new code, on a code coverage of a new code, there is a nice integration of JaCoCo into SonarQube. And in SonarQube, there is a nice concept of so-called leak period. So basically, when you start new development iteration, new leak period starts, and you can observe coverage exactly on what I've just said, on a modified code or on a new code. And over time, you're gonna improve total coverage. Continuing on pitfalls and best practices, it's important to understand how JaCoCo works to successfully integrate it into your chain. The important point is that JaCoCo works only on Java class files. It doesn't require your source code. That's exactly what was shown during a demo, having some Eclipse plugin, Eclipse bundle without having its sources, we were able to measure its code coverage. So how this process looks like, we take our class, there is two modes, either we can pre-instrument it on the disk and then run already instrumented class, already with counters for coverage, or we can do this on the fly. Of course, on the fly is the preferred mode because you don't need to change your build process. You just run Java with Java agents that are gonna do the job. So you then execute this code. After execution, you're gonna get so-called exec files that contains execution information collected by JaCoCo. Then at the time of analysis, you supply original class files, not the class files that were instrumented already, exactly original class files. And only at that point, you might need a source code in order to show a nice highlighting of source code. If you don't have a source code, you still will be able to do an analysis and see percentages down to the method levels, but you're not gonna see the code, that's it. So this was a pretty important moment. From this, there are some other pitfalls and things to be aware of. In OSGI environment, especially in OSGI environment, there is a problem that class name does not necessarily uniquely identify the class. So in order to overcome this problem and correctly associate coverage in a report for different classes but with the same name, JaCoCo uses checksums. And most common problem is that people wonder why they don't see the coverage, but this happens because class file was somehow not the one which was executed at the report generation time. So you can't associate the measurement at analysis time. What can cause different class files? If you use different compiler implementation and you executed the build with class files produced by one compiler and then you try to analyze class files produced by another compiler, bytecode will be different, so checksums will be different, and you're not gonna see a good report. You're gonna see the zeros probably. Different compiler, even different compiler versions, they produce different class files. Different compiler settings produce different class files. So please make sure that at an analysis time you use exactly the same class files as were used for execution. Let's avoid this item. As we seen during a demo, in default mode, code coverage is collected and written on a disk at a JVM termination. If you don't gracefully terminate JVM, if you just do a kill 9, you don't give a chance to JaCoCo to record the coverage and write it on disk. So don't be surprised that if you don't gracefully terminate JVM, that you don't have a coverage. Another important aspect is that to be as performant as possible and to have less impact on performance of your application, JaCoCo injects some fields and methods into classes that are instrumented, purely for performance reasons. And so if you have a library that uses reflection and not expecting some additional fields and methods, this library can be surprised, throw exception, and so on. A good library is gonna ignore such methods because they mark it as synthetic, pretty much like methods and fields that Java compiler itself generates that do not exist in your source code but exist in bytecode. So if you have a problem with reflection, either you need to fix a library, either to ignore such synthetic fields and methods, either you can exclude such classes from analysis, instrumentation, and so Be aware that offline instrumentation, the one that is not performed by Java agent, pre-instrumentation, it requires a direct dependency on JaCoCo runtime. So when you pre-instrument your classes, you need to also put into class path, you need to put JaCoCo runtime. There is some issues with interoperability with other agents. One of the common issues is that order of agents. The general recommendation is that JaCoCo agents should be the first one, and then everything gonna work smoothly. There is some other agents like PowerMock. PowerMock is a strange beast. It bypasses another agents and goes on a disk to read class files. So JaCoCo has no chance to modify the loaded class files. It has some other issues. It also overrides internals of JaCoCo and so on. But don't worry. Read our docs, read our documentation. In case of PowerMock, we are in a contact with developer of PowerMock. We are hoping to resolve this issue. At the end, don't be scared to get in touch, to get involved. Here are some links on our user groups. Here are some links on websites and source code. Don't be scared to contribute something, suggestions. Don't be scared to ask questions if you have some troubles. Any contribution is welcome. You wanna add an item to our frequently asked questions because you face the problem and you think that your solution is gonna be useful for others. Feel free to propose that. You would like to build example how integrate code coverage measurement into some application, I don't know, into how to integrate it with Spring Boot and so on. Don't be afraid to propose such example. And that's it. We have a bit of time, 3 minutes for questions. They are welcome, and don't forget to evaluate the sessions. So, questions?
On SonarQube, do you do some kind of selenium testing, for instance, and do you then try to instrument the gradient to also that coverage up to Eclipse testing?
Okay, let me repeat the question. On SonarQube itself, I assume during development of SonarQube, do we do some selenium testing and do we try to measure code coverage of such functional tests? The short answer will be yes, we do selenium testing, testing with selenium, and no, we don't measure coverage of those tests. This will be the short answer. The long answer will be, we tried, we had such setup, but at the end, we decided to not do this because it harms a little bit, because such a functional test, they touch a lot of your application, whereas they do just a little of assertions. So such coverage was badly incepted by developers. They were believing that everything is covered, everything is good, whereas in reality it is not. So nowadays we better focus on more granular tests, on unit tests. Some other question? If not, thank you for your attention. Have a great day. If you will accidentally get questions or would like to chat about bytecode instrumentation, SonarQube or whatever, feel free to catch me and we will have a talk.